Hey, welcome back. Here's a math problem for you. Question: what does 427 cubic inches of Windsor plus one giant blower equal? How about 1,220 righteous horsepower? For our latest build, we're back at the shops of Prestige Motorsports in Concord, North Carolina, where they are putting together this big hitch Windsor for a customer that wants to put enough horsepower into his 1968 Mustang to hurt feelings and make little children cry. So, of course, they said, no problem. We did run into one issue on the dyno that would have put a lot of engine builders into the wall. And the fix was pretty interesting if you ask me. So make sure you stick around for that. To handle all the power they plan to make, Prestige is starting with a cast iron Dart SHP block with a 9.5 inch deck. The cylinder bores have been knocked out to 4 inches 125 thousandths, while Prestige's machine shop blueprinted all the other critical dimensions. But even with the larger cylinder bores, the Dart block cylinder wall should be at least 290 thousandths of an inch thick. Plenty to handle well over 1,000 horsepower. You will notice the block has already been cut to accept O-rings. Ford Windsors aren't exactly blessed with an abundance of head bolt mounting holes, and cylinder sealing can be an issue in high horsepower builds. So, we'll be using O-rings to help out there. Short block specialist Cody McCleary performs all the pre-fit checks on the block, including file fitting the rings and checking the bearing clearances. We're using King's XP series main and rod bearings for this build. The XP is King's bearing line purpose-built for racing. For example, the main bearings are narrower than standard to make room for large fillets used to strengthen the main journals on racing cranks. And that funky bronze, black, whatever you want to call it, color isn't a coating. It's King's outer alloy using copper to make it harder and significantly more resistant to wear than a typical lead Babbitt bearing. Anyhow, going into those bearing saddles will be a forged eagle crank with 3 inch mains and 2 inch 100,000th rod journals. It'll be swinging the rods and pistons on a 4 inch stroke, and since it will be pushing against forced induction, it absolutely must be strong. After lubricating the main bearings, McCleary gently lowers the eagle crank into place. He slides the one-piece rear main seal on and then begins installing the main caps. The SHP block uses steel 4-bolt mains with deep registers to locate each cap. Then everything is torqued down. The inner bolts are big half-inchers and torqued down to 100 foot-pounds, while the outers are slightly smaller at 7/16 and torqued to 70 pounds. Before fully assembling the rotating assembly, McCleary's engine assembly teammate Larry Broker quickly mocks up one rod and piston to check the piston to valve clearance. Here, you can see that instead of installing a set of rings, he's wrapped a couple of passes of masking tape around the top of the piston to hold it stable in the cylinder bore. This is a pretty unique build with an aggressive cam, so there is the possibility that they may need to cut custom valve pockets in the piston tops, so it's good to check before it gets too far. The guys at Prestige worked with comp cams to develop the grind for this build. The cam is a solid roller that's ground with 256 degrees of duration at 50 thousandths tappet lift for the intakes and 265 degrees for the exhausts. Tappet lift is 390 thousandths for the intakes and 395 for the exhausts. So with 1.7 to 1 ratio rocker arms for the intakes and slightly smaller 1.65 to 1 for the exhausts, gross valve lift will be 663 and 652. Now that the cam is in place and degreed in, Broker can check valve drop. With a little math and tracking the cam lobe, he can calculate when both the intake and exhaust valves should be closest to the piston and check the valve movement manually. Using this method, he doesn't require the valve train, including the rocker arms and the push rods, to be installed. As part of the pre-assembly process, he also checks the combustion chamber volume. These are a pair of Edelbrock Victor cylinder heads. Prestige has already sent them out for custom CNC port work, so the 47cc combustion chambers these heads came with have been opened up to 64.5. We'll get to all the rest of the details on these heads in just a minute. With all the pre-checks out of the way, let's get back to completing the rotating assembly. The connecting rods are a set of Compstar forgings from Callie's. These H-beam rods are 6 inches 200 thousandths long with a bush pin in and 7/16 ARP 2000 cap screw bolts. Callie's Compstar connecting rods are designed for high horsepower and stroker applications. And you can see how the angle on the edge of the rod is continued all the way through the underside of the cap screws to make just a bit more room between the big end of the rod and the cam lobes. Prestige has a strong relationship with DSS Racing Pistons, so we're using a set of their 2618 forgings. These 4 1/8 inch diameter forgings are DSS Racing's FX series of pistons designed to work in max effort builds. There is a 30cc dish to help keep the compression ratio down to 9.16 to 1. Now that may seem low at first, but it does allow the owner to run more boost while still burning pump gas. The ring lands are relatively thin and will work with a 1.2, 1.5, and 3 millimeter ring pack. Combine that with an inch 280 thousandths compression height. That's the distance from the center of the wrist pin bore to the top of the piston. And that means the oil ring land can fit without cutting into the wrist pin bore and require a support rail. The rings, by the way, are gapped at 35 thousandths for the top and second rings to account for all that heat from combustion. McCleary cleans and adds a light coat of motor oil to the cylinder bores, then paints assembly lube on the crank's rod journals, and he's ready to install the pistons and rods. To get proper stretch, the cap screws are torqued to 75 foot-pounds. Once everything is together, you can see one nice feature of the SHP block. Extended bores prevent too much of the piston skirt from being exposed at bottom dead center, even though we're running an extra ½ inch of stroke in this build. Now the short block moves over to Larry Broker's area for finishing. To provide plenty of oil to all the critical areas of the engine, Prestige chose a Melling high-volume oil pump. It will be pulling oil from the Canton steel oil pan. The kickouts give it a 7-quart capacity if you're counting the oil filter, and as you can see, it's a front sump to fit early Mustang chassis. The pan is also designed to work with stroker applications, and with its 8-inch deep depth, it can handle our 4-inch stroke no problem. The damper is an SFI certified unit from Innovators West. Since it's going to be spinning up a centrifugal supercharger, Prestige has had it cut with 2 keyways instead of just the standard single keyway setup. The CompCam solid roller cam has already been installed. Broker lubricates the lifter bores before dropping in the lifters. Like with most of its high horsepower builds, Prestige is using a set of BAM's solid roller link bar lifters. Next up comes a set of 1/2-inch ARP head studs. Broker runs them down until they just touch in the bottom of the threaded holes. And with that, we're back around to the cylinder heads. Notice that they've already been cut for O-rings like the block. Before installing the valves and springs, Prestige checks the quality of the CNC port work by putting them on the flow bench to see just how much air they can move. And these heads did not disappoint. The intake ports actually moved a peak of 331 CFM at 691 thousandths valve lift. Some people think that if you're running boost, either with a turbo or some type of supercharger, the port quality doesn't matter because you can just mash more air in there. But a poor port raises temperatures, backs up air in the intake plenum, giving you an artificially high boost reading, and generally makes the engine work harder than necessary. A quality, high-flowing cylinder head port simply helps the engine work more efficiently. After the flow bench testing is complete, Cody McCleary installs the stainless steel wire in the cylinder heads for the O-rings. The O-ring material is 39 thousandths thick hardened wire that's pressed into a 29 thousandths deep groove in the cylinder heads. Often, you see the O-ring pressed into the block to push the head gasket material into a groove in the cylinder head. But for this build, Prestige prefers to install the O-rings into the head. And the reasoning is pretty simple. The receiver O-ring groove works best when it maintains a sharp edge so it can bite into the gasket. If you have to pull the cylinder heads off for repairs and install them back on, it can round off the edges of the soft aluminum every time the gasket material is pressed into the groove by the O-ring in the block. Since the cast iron block is harder, Prestige prefers to install the O-ring into the cylinder head and use it to press the gasket into the receiver groove in the block. And here we are with both the O-rings and the valves installed. We're running a set of Manley stainless steel valves to seal off the 64.5cc combustion chambers. The intakes are 2 inches 125 thousandths in diameter, while the exhausts are 1 inch 625. The head gaskets to seal the decks are copper because they work best with O-rings. They're manufactured by Flatout and are 40 thousandths thick. Now here's a better shot of the CNC cut intake ports. They measure out, by the way, at 240 cc's each with the custom port work. Edelbrock's Victor casting also raises the intake ports 380 thousandths versus a standard Windsor head to further improve flow. The Edelbrock Victor heads are for all-out competition, so they won't work with standard pedestal rocker arms. Instead, we're using a more stable set of shaft mount rocker arms from T&D Machine Products. Here, Broker sets the rocker stands in place and secures them with bolts of 60 foot-pounds. Some of these bolts extend into the intake passages, so Loctite is used to make sure everything is sealed so that no air, fuel, or oil can wick past the threads. The valve springs are a nested setup from AFR. They are installed at 1 inch 950 thousandths height and have 550 pounds per inch spring rate. Retainers and locks are both steel. We'll be running offset intake rockers, so the push rods will be 2 different lengths. After some checking, Broker wound up with 8 inch 700 thousandths intake push rods and 8 inch 680 thousandths for the exhaust. Both are 3/8 inches in diameter with an 80 thousandths wall thickness. And with the push rods in place, we can turn our attention to the shaft mount rockers. These aluminum rockers from T&D have a 1/2 inch offset for the intakes. This helps clean up the geometry by moving the push rod holes out of the way so that the intake ports can be optimized for flow. The ratios are also pretty strong, like I've already mentioned. 1.7 to 1 for the intakes and 1.65 to 1 for the exhausts. The rockers mount up in pairs and then are bolted down and torqued to 25 pounds. Once they're all in place, Broker sets the cold lash for both the intakes and exhausts to 12 thousandths. This should get us close to the hot lash target of 18 thousandths of an inch for the intakes and 20 for the exhausts. And we'll dial that in closer once the Big Ford is up and running on the engine dyno. The intake manifold we'll be using is a single plane from Bill Mitchell Products. The guys at Prestige have already modified to work with their fuel injection system. But before it can go on, a little custom fab work is called for. Edelbrock made a lot of changes to their Victor cylinder heads to help for higher horsepower Windsors, including standing the valves up at a 15-degree angle, raising the intake ports 380 thousandths and the exhaust ports even higher at 520 thousandths. Thankfully, Edelbrock extended the intake flanges on these heads, so you can still use a standard intake like we are here. But with a 9 inch 500 thousandths deck, it raises the bottom of the intake up off the block's china rail more than normal. To fix this, Broker creates valley spacers by tracing the gaskets onto a piece of 1/2 inch aluminum plate and then cuts them out. Once that's done, you can see how it helps seal everything up on this test fit. and then everything gets a good coat of ultra gray RTV silicone to make sure it seals up tight. The yellow masking tape just makes sure that any excess silicone peels right off without leaving any residue on the engine. And then all the intake manifold bolts are tightened down securely so that the silicone can dry without being disturbed. This is one of Holley's dual sync distributors. For this build, we'll be fitting up individual coil packs, so technically a distributor isn't necessary. We still, however, need a cam position sensor for the Holley Terminator X ECU to work properly, so the distributor cap is swapped out for a billet aluminum blank. The plug wires will come from the Holley smart coils we'll be using, and they'll be mounted at the back of the engine. And now we can move on to the really good stuff, the Vortech V-7 YSI blower, providing boatloads of pressurized air to the combustion chambers so we can make big power. Prestige worked with Concept One to develop a custom pulley system that could spin up both the Vortech blower while also driving the engine accessories, all in a super sanitary package. The brackets have all been powder-coated black to go with the overall look of the engine, and the water pump has been painted black to match. Here, you can see how the Vortech blower mounts up high on the passenger side. This is the best place to locate it so it doesn't interfere with the chassis. Plus, it's going to get plenty of attention whenever the owner opens the hood. The brackets are an inch thick billet aluminum and use plenty of fasteners to hold everything steady, which is critical because, let's face it, nobody wants to be throwing blower belts. Vortech's V7 series centrifugal superchargers are designed to provide big blower performance in a smaller package. They have an internal step-up ratio of 3.45 to 1 and a maximum speed of 65,000 RPM. That equates to a maximum flow of 1600 CFM and the capability of producing over 1200 horsepower, which makes this blower a great choice for highly modified engines exactly like the Haas we're building. Notice also that the V7 blower receives pressurized oil to keep the gears and bearings cool through this AN line. Then it gets dumped into the oil pan to be recirculated. On the dyno, the supercharger is plumbed up to Prestige's dyno setup with an air-to-water intercooler out front and a blow-off valve up top. The cooled and pressurized air enters the engine through a Pro Series carb hat made by Extreme Velocity. Prestige owner Doug Aiken says he likes using this hat for high horsepower builds because its well-designed short turn helps direct air right into the throttle body, and the hat in general simply moves more air than other options. Underneath that is a Dominator flange throttle body from Holley. This is a 4-hole throttle body with 2¼ inch bores, meaning it can flow a hefty 2000 CFM. Exactly what we need for a high boost. Adding the fuel to all that air will be a pair of Edelbrock fuel rails and 8 high-flowing 1650 cc fuel injectors from Fuel Injector Clinic. And here's a shot of the Holley smart coils that'll be providing the spark. Now this setup obviously won't work on a car. It's just for simplicity on the dyno. And they, along with everything else, will be controlled by a Holley Terminator X ECU. The headers are Prestige's standard dyno set of Schoenfelds with an 1 3/4 primaries expanding to 1 7/8 pipe. So that's that. It's time to put this bad boy to work. We didn't want to pull air into the supercharger from right across those hot header pipes, so you can see the elbow in the inlet pipe to pull in cool, clean air. So after a short break-in and a check of the plugs and valve lash, we're ready to start making some power runs. always runs the dyno at Prestige, and he made pulls from 3,500 RPM all the way to 6,700. The boosted Ford came right out of the gate strong with 580 foot-pounds of torque way down low and just kept climbing and climbing and climbing. We hit peaks of 833.9 foot-pounds of torque at 6,000 RPM and a jaw-dropping 1,004.5 horsepower at 6,700. I say jaw-dropping because we're doing that just running 93 octane pump gas and running a mere 12.9 pounds of boost. That's the boost scale on the right-hand side of the chart. As you can see, we didn't hit peak power on the run, but pulled the handle back at 6,700 RPM because we didn't want to exceed much more than 1,000 horsepower on 93 octane. Also, if you're curious, that was 21 degrees of total timing by the end of the pull. This engine is overbuilt, if anything, and should be able to run at those power levels all day long without an issue. But it turns out that this was with the big 34 tooth pulley on the Vortech. So before the engine was even cool, Senior was swapping out the drive pulley for a smaller 28 tooth unit that will increase the blower speed and push even more air and fuel into the engine. After installing the pulley set and screwing in a fresh set of plugs gapped to 18 thousandths, Senior drained the pump gas for some fresh C16 race fuel, and just like that, it's time for round 2. Did you hear it? At the Horsepower Monster, we give you the whole build and don't hide anything. Unfortunately, we ran into a bit of an issue, which we mentioned early in the video. At the top of the pull, the Ford was acting like it picked up a miss. And when running a few checks and trying to tune it out on the ECU, Senior suspected that the added boost and cylinder pressure was lifting the cylinder heads. But instead of stopping there and simply telling the customer that this engine is good for 1,000 horsepower, which is plenty impressive in its own right, the guys at Prestige decided to pull it down and get back to work. This is the kind of thing that separates the winners from the rest of the pack in my book. So here we are a couple of weeks later. The engine has been completely disassembled so that everything, including the bearings, can be checked over. They did determine that they were, in fact, getting exhaust gases leaking past the original O-rings. So they decided to go with a serious upgrade, switching out the O-rings for these bad boys. These are what's known as either fire rings or fire hoops or top fuel hoops. But no matter what you call them, they are a serious upgrade over traditional O-rings. Instead of using a hardened wire, these hoops are machined exactly the size and are perfectly round. As you can see, they're also much bigger. Here, Cody McCleary cuts new grooves into the heads for the hoops. This time, they're cut 60 thousandths deep for the 80 thousandths tall hoops. That leaves 20 thousandths worth of hoop pushing the copper head gasket into the receiver groove in the block. Once the new hoops are tapped into place, the entire engine had to be rebuilt. Now I know you don't have time for all that, so we'll just skip forward till we're back on the dyno again. This time, we're running a set of plug wires, which is just because Prestige got a new set of wires for the dyno, but everything else is exactly the same. Of course, that's with the exception that we also installed an air cleaner on the inlet pipe, which wasn't there for the first test. But that's okay, because if anything, the air cleaner will hurt power, so as long as we see more juice from this Ford, we know we're good to go. And right away, we learned some things on the very first pull. Namely, make sure your air cleaner is clamped down really tight. So the information from that pull is garbage. But after that, we started making some serious gains. We settled on 32 degrees of base timing and pulled timing out as the boost increased. Total timing at max boost is 28 degrees, and we're still on the same VP race fuel as before. top fuel hoops in place, our head lifting issues were cured for good, and the power jumped up right where Senior expected it to be. Just by switching out the pulleys, we went from 580 foot-pounds of torque when the pull started at 3,500 RPM all the way to 662.2. Our peak torque jumped nearly 218 foot-pounds and broke the 1,000 barrier when it got to 1,051.6 foot-pounds at 6,000 RPM. That will make for some absolutely vicious acceleration. This time around, we didn't make the pull all the way to 6,700 RPM, but stopped at 6,400 because the power had already shot past 1,200 horsepower. But we did see a maximum of an incredible 1,227.8 at 6,400 RPM. That was with 16.58 pounds of boost. Overall, I think this 427 cubic inch Ford is an unqualified beast. I could listen to this thing make rips all day long. Anyhow, if you like this video, I bet you'll love these other builds we've shot as well. So check them out. Hey, thanks for watching, and we'll see you next time.